Welcome back. I finally finished my new edge belt sander table. Because of the way I work, this kind of edge belt sander is one of the tools I rely on most, and I use it in almost all of my projects. I designed it with portability in mind, and so I can mount it on almost any kind of workbench. This is the one I've been using for a couple years. As you can see, it's simply a portable belt sander that's been rotated and attached to a table. The problem is, it lacks power. The belt is short and the wheels, one of the parts I use most, are not easily accessible. Placing and removing the sanding belt is quite easy. You only have to loosen or tighten this tensioner. I can calibrate the sanding belt by tightening and loosening this screw. In the end, I decided to place this third wheel to calibrate the belt because I needed the other two to be firmly locked and in proper alignment to avoid imperfections when operating it. I've also developed this dust collection system. I can put it in line with a belt or rotate it to different positions. I'm going to perform some tests to show you how the sander works. First, at a 90-degree angle. And here, with pieces rotated to a 45-degree angle. This way I can sand the longer pieces edgewise, and the dust collection system works the same way. I'll try the sanding wheels on this electric guitar body. It's a great example because it has several kinds of curves. The big wheel will be most useful when sanding wide curves such as this one. The straight part of the sander is for this kind of curves, and the small wheel is for tight, hard-to-access curves. This is the 3D file you'll find in the plans. These are the two pieces I'll make first, the sander's base and top. I cut all the necessary pieces with a table saw. I glue the printable template onto the plywood to mark the holes we need on the top. I can use those to mark the same holes on the base and make sure the wheels are aligned with the base. After screwing it together temporarily, I drill the holes with this plunge router rig with a drill. With this straight bit, I mark the position of the bearings. Having marked both pieces, I drill a hole for the bearings. Now I can screw the base to these legs. I cut the contour of the top, and after sanding the edges, I make a rebate for the belt tensioner. Now I'll make a hole for the motor with this plunge router. This kind of motor is attached to the front, making it ideal for this purpose. I finished the job with a jigsaw. I glue the printable template to cut the hole that will allow me to rotate the dust collection system, and do the same with the gap where the belt tensioner will be. Now I'll build the sander's bigger traction wheel. I mark all the pieces and cut them with the jigsaw. The lathe sanding disc will come in handy to make them all perfectly round. I'll use the wheel's rod itself to function as axes like this. I make this little groove in the rod with an angle grinder. Now I mark the position of the pieces on the rod and glue them together. When the glue is dry, I'll use the screw like this to lock the wheel to the rod. I put the bearings and the sander's wheels in place. These are the aluminum ones I made in my previous video. I put in all the necessary washers and now I can attach the top. I cut the straight part that's in contact with the belt and screw it in. First the top and, after making sure it's properly aligned with the base, the bottom. This is the belt tensioner. After verifying it's the right size, I drill holes for the two screws that will serve as rotation axes. I used a bit 1 mm less than the diameter of the screw. I'll test everything with a drill anchored to the traction wheel. This got me to think that this design could be adapted to be used with a drill, whether on the top or on the bottom. The second part is coming up in a few days, look forward to it.